Before doing this next problem on simplifying expressions involving quadratic equations or quadratic expressions, let's do a quick review, and this really should be review, on simplifying expressions, or in this case, fractions in general. So if I have this fraction here on the left, 3a all over a times b, I can just cancel out this a here, which means this should be equal to 3 over b. And the reason I can do that is because when you are multiplying fractions, what you are doing is you just multiply straight across. You do not need to get a common denominator or anything like that. So this means this expression here, 3a over a times b, should be equal to a over a times 3 over b, because a times 3 is the same as 3 times a, and here we get a times b on the bottom. In other words, I can get back from here back to here. I can reverse engineer my way from here back to here. Therefore, I know these two things are equal. And so if I have this here, a over a, that's just 1. So that is the same as 1 times 3 over b, which is just 3 over b. And so I am always a bit astounded when people then make this mistake. Because like I said, the reason that I know I can do this isn't because I memorized it by reading it in a textbook somewhere. I know I can do it because I can reverse engineer my way back from here to here. I can prove to myself that these two things really are equal. So this is legit. Now, what you never want to do is this over here. If you are given an expression or a fraction such as this, a plus 3 all over a plus b, you never want to split your denominator. If you do that, you will go straight to a GMAT jail, and nobody, including myself, will have any sympathy for you. So if you cross out this a here, if you cancel out this a here and say this here is equal to 3 over b, well, does this make any sense? I'm always astounded when people do this because there are so many ways that you can prove to yourself that this should not be true. So if someone says this, they're wrong. This is, in fact, these two things are not equal to each other. So if they were to just plug in some numbers, plug in numbers for a and b, and you should almost certainly see that a plus 3 over a plus b will not be equal to 3 over b. But also, we were able to reverse engineer our way from 3 over b back to here. In this case, we would not be able to do that. And so the fact that you cannot get back from here to here is really what should tell you that these two things are not equal. And if you did something like this, you really just sort of made something up. And so think about even what you did. So if you were to do this, so you're sort of saying this is equal to a over a plus 3 over b. But even then, you sort of you misapplied a non-existent rule, because if this were true, this wouldn't be 3 over b. This would be equal to a over a is 1. So this would be 1 plus 3 over b. So this doesn't really make any sense. But the real reason is because you cannot reverse engineer your way back from this to this. And so because we are adding in our top and our bottom here, all you can really do is you can say when we are adding fractions, we need to get a common denominator. Therefore, a plus 3 over a plus b should be equal to a over a plus b plus 3 over a plus b. And you can reverse engineer your way then back from this back to here. But there's really not anything more that you can do with this guy here. You certainly cannot cancel out this a or anything like that. So I don't even know if you would want to necessarily break it up like this. But you could do this if for some reason you had to. Now say, we're going back to our guy on our left here. And by the way, this all assumes that either a or b is equal to 0, because we cannot be dividing by 0. Going back to here, say we were told that a is equal to x plus 3. If that were true, we would have, say, a is equal to x plus 3 and b is equal to 5. We would have 3 times x plus 3 all over x plus 3 times 5. And this would be equal to 3 over 5 because our x plus 3 would cancel out. Now, even though there is an addition sign here, it is still 3 times this whole quantity, x plus 3. And so if you ever get confused, if can I cancel something out even though I have this addition sign here? Well, just think of it like this. So say, rewrite this equation here as 3a over a, this times 5, where a is just equal to x plus 3. And since you can cancel out the a here, you should be able to cancel out the x plus 3 as well. What you cannot do is, when you have two addition or subtraction expressions over each other, you cannot split your denominator. Here, even though it might look like we have an addition expression, this is really we have two multiplication expressions on top and bottom. And that is why factoring is such a useful skill, because when you are factoring, usually what you are doing is you are taking an addition or subtraction expression and you are converting it into a multiplication expression, which you can then use to combine or cancel things out like we did here. You are using your divisibility rules to your favor. Now let's look at an actual GMAT type question, and one involving simplifying with quadratics. This just says x squared plus 2x all over 4 plus 3x plus 6 all over 3, then all of that over 2x cubed plus 10x squared plus 12x is equal to what? So really, without saying so, they're just asking us to simplify this expression here. So let's start by just rewriting it. And then I wouldn't say there's necessarily any one best place to start, but just sort of break it up into chunks. So I'll start, for example, let's start with the denominator. And then the goal is to cancel out or combine as many things as we can. And then we'll start working on the numerator. And so the order in which I do things, there really isn't a single optimal order. So easy things first. This might look like a quadratic here, but I have this x cubed here. And from our previous video, we know that quadratics take the form of ax squared plus bx plus c. So it might sort of look like a quadratic, but I need to get rid of this 3, this power of 3 here. And so the most obvious thing that it looks like I can do is I can factor out an x here. And really, I can factor out a 2x because 2, 10, and 12 share a 2. And they also, all of my terms share an x. So I'm going to factor out a 2x. So 2x times what gets me back to 2x cubed. That should be x squared. We're just reverse engineering our exponent rules here. Then to get from 2x to 10x squared, I need a 5x here. And then to get from 2x to 12x, this would be a plus 6. And so if I'm going step by step, we'll leave the numerator as is. Then we will focus on that next step. And so here, I want to get a common denominator. I want to combine the two fractions in my numerator to a single one. And so common denominator would be 12. So I'm multiplying this guy by 3 over 3. This guy here by 4 over 4. Which gets me to 3x squared plus 6x all over 12. Plus 12x plus 24 all over 12. And that is all over our simplified denominator of 2x times x squared plus 5x plus 6. So now we can just combine our two fractions in our numerator. So 3x squared plus 6x plus 12x plus 24. 6x plus 12x is just 18x. So this is 3x squared plus 18x plus 24. All over 12 all over 2x times x squared plus 5x plus 6. So it looks like we still have some simplifying to do in our numerator. I don't want a fraction over some other expression. I just want a single numerator and denominator. So I can factor out a 3 from my numerator up top. So that will leave me just with 3 times x squared plus 6x plus 8. So now I'm sort of happy because I didn't before, but now I have a quadratic here and I have a quadratic here. And hopefully I will be able to factor those, and that will allow me to cancel out even more stuff. And so this is all over 12. Then all of this is still over 2x times x squared plus 5x plus 6. I feel like we're getting close to the end, so let's start going horizontally. So here, my 3 and my 12, that just simplifies to 1 over 4, so I'm left with just a 1 over a 4 on the bottom there. And then it looks like I can factor my two quadratic equations. So how would this guy factor? I need something that multiplies to 8, but sums to 6. 2 and 4. So x plus 2 times x plus 4. All over 4. That is all over 2x. How does this guy factor? Now I need something that multiplies to 6, but sums to 5, 2, and 3. Seem like they will do the job. And now, dividing a fraction by some expression is just the same as multiplying by the reciprocal. So this is really x plus 2 times x plus 4 all over 4 times the reciprocal of 2x times x plus 2 times x plus 3. So 1 over 2x times x plus 2 times x plus 3. Then my x plus 2's cancel out. I'm left with just x plus 4 all over 8x times x plus 3. And then sometimes, I would say this is fully simplified, but sometimes with these questions where they're asking you to just simplify something, you need to sort of, once you have your work is simplified, you need to look at the answer choices just to see how they want it formatted. So I don't know if I will have to multiply this out or not. X plus 4 over 8x times x plus 3. And it looks like I don't, because C is exactly what we got. That's it. This question might look complicated. It should not be. This is mostly review, knowing how to combine fractions, how to factor things. The factoring these quadratics here was really only one part of this problem. And so this, I would say this is a 500 to 600 level type question. So you should be able to do it backwards and forwards.